7, 8, our last section of the year, we're going to do partial fractions. So what we're going to do is we're going to do some decomposition of these. So a little bit of review. Back in the previous chapter, we added these two together. Remember, to add these together, I have to have common denominators, which would be x and x plus 1. Okay, so here I need to multiply both sides by x. That gave me 2x. Here I have to multiply both top and bottom by x plus 1, which gave me 3x plus 3. Okay, now that I have common denominators, I can add like terms together. So I have 5x plus 3 over x times x plus 1. Okay, so a little bit of review. So what we're going to do now is we're going to do the decomposition of these. So we're going to take this and we're going to try and write it as a composition of factors. So this and this. Okay, so we're going to go in the opposite direction. Let's take a break from those notes and do a couple that are just a little bit easier. Okay, because the notes get pretty complicated pretty quick. So let's do this. So the first thing we want to do is make sure the denominator here is a lesser degree. Okay, so this is a degree 1, this is degree 2, so we're good there. If not, you would have to use your division. Okay. So what we're going to do is we're going to factor the bottom here. This will be x plus 9 and x plus 3. So we know we're going to separate this into some number over our linear factors, x plus 9, plus some number over our x plus 3. Okay, so we got to find our a and our b here. So what we're going to do is we're going to solve this equation, multiply both sides of the equation by x plus 9 and x plus 3 to eliminate the fractions. So this times this over here, those cancel. I have 2x plus 12. X plus 9's cancel, so I have a times x plus 3. And here those cancel, so I have b and x plus 9 left. Okay, now to solve for the a and b, the easiest thing to do is probably pick a number. So let's just say x equals something that will eliminate either of these variables. Okay, so if I say x equals -9. Okay, so -9 plus 9 would be 0, b times 0 is 0, right? So I don't want to be left with the a term, so let's do that. So 2 times -9 is -18. -18 plus 12 would be -6. Okay, -9 plus 3 is -6. And we said that was going to be 0, right? So when I solve this, I get a is equal to 1. Okay, same thing for the other variable. Let's make x equal to a number that's going to get rid of this term. So let's say x is -3. So when I plug it in, 3 times -3 is -6, plus 12 is 6. -3 plus 3 is 0, 8 times 0 is 0, and then -3 plus 9 is 6, so we have 6b. So I get b is also equal to 1. Okay, so now I'm ready to get my answer here. My answer is going to be is equal to a, which is 1, plus the b, which is also 1, and there's my solution. Okay, let's try another one. Okay, so once again, this is the degree is smaller, so we're good to go. So it's going to be, factor this out, x minus 4 and x minus 5. Okay, so we know it's going to be some number over x minus 4 plus some number over x minus 5. Okay, so I'm going to take this and multiply it by x minus 4 and x minus 5 to get rid of the denominators. So I know that negative x plus 3, they both cancel, is equal to a times x minus 5 plus b times x minus 4. One of these 0. Let's say x is equal to 4. So when I plug 4 in for the x, -4 plus 3 is -1. And we have a times 4 minus 5 would be -1, and this would be 0. So when I solve this, I get a equals 1. Okay, so let's do the other one. So if x is a 5, -5 plus 2 would be, plus 3 would be -2. 5 minus 5 is 0, is crosses out, and I have 5 minus 4 would be 1, so B1. So I get A and our B. So my answer, I know that this will equal my A, which is 1 over x minus 4, plus my B, which is negative 2 over x minus 5. Okay? Now, in the notes, we're going to get just a little bit harder than that yet. Okay, so now we'll get to the ones in our notes here. So what we want to do here is we want to, since the degree is higher on the top than the bottom, we want to do our long division. Okay? So if I do that x to the third minus 4x divided into this, hopefully you remember this from before. We know that 2x times this will give us this, right? So 2x to the fourth minus 8x squared. And remember how we drew the line, changed the signs, and we came up with our remainder right here. So this is 2x plus 5x minus 2 over my x to the third minus 4x. Okay? So now what we're going to do here is we want to do the decomposition on this part right here. So 5x minus 2 over our x to the third minus 4x. Okay? So what we want to do is we want to break this down into linear terms. So this is x times x squared minus 4, which is x times x plus 2 and x minus 2. Okay? So I know that this is going to break down into some number times x plus some number times x plus 2 plus some number times x minus 2. Okay? Now, to solve this equation, I'm going to multiply by x plus 2 and x minus 2. Well, they're both eliminate there, so I just have the equation 5x minus 2 equals a. The x's will cancel, but it's x plus 2 and x minus 2 left, plus b. I have x and x minus 2 left, plus c, and I have x and x plus 2 left. Okay? So now, I have an equation to solve here. Okay? So let's try and eliminate some of the variables. Okay? So let's say if x equals 0, and I chose 0 because that'll eliminate this term and it'll eliminate this term. Okay? So if I plug 0 in here, 5 times 0 is 0, and so I have negative 2, and equals a, and 0 plus 2 is 2, 0 minus 2 is negative 2, so I have negative 4. And 0 here makes that 0 and 0. So if I solve this, I get a is equal to 1/2. Okay? Now, if I know a is 1/2, I can put a 1/2 right in there if I want to. Okay? So we can substitute it back in. Let's try and get everything to be 0 except for this one. So let's say x is a negative 2. So if x is a negative 2, then negative 2 plus 2 is 0, and negative 2 plus 2 is 0, right? So those two will cross out. So if I plug a negative 2 in here, 5 times negative 2 is negative 10, minus 2 more is negative 12. Okay, plug a negative 2 in here is 0, plug a negative 2 in here is 0. I get b, and negative 2 and negative 4 gives me 8. So I get b is equal to negative 3 over 2. Okay, and then I wanted the c to be here, but I want these to be gone. Okay, so let's look at the x minus 2. So let's make x equals 2. So if x is 2, 2 minus 2 is 0, makes this 0, and same thing there. 5 times 2 is 10, 10 minus 2 is 8, and those are zeros, and then I'd have 2, and 2 plus 2 is 4. So 2 times 4 is 8. So I'd have 8 times c, so c is equal to 1. Okay, so I know that my final answer, this whole thing, is going to break down into 2x plus, okay, and then this part decomposed into my a, which is a 1/2. So 1/2 over x. You could also write that as 1 over 2x. That'd be okay as well. plus b, which is negative 3 over 2 over x plus 2. Another way to write that is negative 3 over 2 times x plus 2. And plus c, which is a 1 over my x minus 2. So right there is my answer. You can substitute those into them as well. Okay? Now, the next one we have here okay, I'm going to use a different color just to keep it separate a little bit. When we have multiple factors down here that are the same. So here we had multiple factors, right? X plus 2, and x minus 2, but what if they're the same? So what we're going to have to do for this one, so there's no, first of all, there's no division because this would be x to the third. It's higher in the bottom, right? So we're going to separate it into a over x minus 1. Okay, now, it's going to be b and x minus 1 squared, and c and x minus 1 to the third. And if this would be to the fourth, we'd add another d and x minus 1 to the fourth. Okay, so that's how we're going to set it up. So we have to solve this. We're going to multiply everything by x minus 1 to the third power. So here they both cancel out. I'm just left with 2x. Here one of them cancels out, so I'll have a times x minus 1 squared. B, two of them cancel, so I'm just left with x minus 1. And plus c. Okay. Now, try and solve some of these things here. Okay, so let's see what x's can I put in here to make something eliminate. So if I put x equals 1 in here, that'd be 1 minus 1 and 1 minus 1 would both be zeros, right? So I'd be just left with c. So let's say that x equals 1. Then 2 times 1 would be 2. And this would be 0, and that would be 0, so I have c. So I know that c is equal to 2. Now, if I plug that back into this equation, I know that 2x, well, I'll write it down here. 2x is equal to a times x minus 1 squared plus b times x minus 1 plus 2. Okay. Now I can't really use this idea of plugging a number in to get rid of the other two variables, right? So for these, there's nothing I can plug in because they both have x minus 1s there. Okay, so this is where my system of equations is going to come up. So I'm going to take this, I'm going to make two different equations. I can just pick any x at all. Okay, what's an easy x to plug in here? Let's take x equals, I don't know, 1. You could use 10, you could use 15, whatever you want. I'm just going to use, well, I can't use 1 because 1 minus 1 would be 0, right? So that would get rid of those terms. So let's use 0 and x equals 2. Okay, we'll just kind of, 0 is always easy, right? Okay, so if I plug those in here, 2 times 0 would be 0. And 0 minus 1 would be negative 1. Negative 1 squared would be 1, so I have 1a. 0 minus 1 is negative 1, so I have negative 1b plus 2. And the form that we've been seeing it all chapter would be a minus b is equal to, subtract that over, is equal to negative 2. So there's one equation for our system. If I use x equals 2, 2 times 2 is 4. And then plug in a 2, 2 minus 1 is 1, 1 squared is 1, 1a. Plug in a 2, 2 minus 1 is 1, so I have 1b plus 2. So I know that a plus b is going to equal, subtract this over, I get 2. So here I have my two equations, my a and my b, and you can choose whatever method you want to use here. Okay, put those two together. Elimination is really nice to use, right, because the b's will eliminate already. So I would get, when you solve this, you would get a is equal to 0, and you get b is equal to 2. Okay, so we now know our a, our b, and our c. So my answer, my final answer is going to be equal my a, which was 0, and 0 over x minus 1 is just 0, right? Plus b, which is 2 over x minus 1 squared, plus c, which is also 2 over x minus 1 to the third. Okay, so right there I have my solution to that problem. Okay, now number 3. Okay, number 3 here, which I'm going to keep getting a little bit different. So the first ones we talked about were just linear, right, when we have linear factors. And then we have linear factors that repeat. Now we have a linear and we have a quadratic. Okay, so how are we going to work with this? I'm going to switch to the blue pen again. So we're going to separate this into some number over x plus 1. Okay, now with this one, since this is a quadratic, we're going to go to 1 degree less. So this would be an x. So I need bx and then a constant term with it, c. If this would be a cubic, we would do bx squared plus cx plus, plus d. Okay, so we have this to solve. So, okay, here we go to solve. So when I solve this, I'm going to multiply everything by x squared plus 2 and x plus 1. Here they both cancel. I have the equation x squared plus 3x minus 1. A times x squared plus 2 plus bx plus c times x plus 1. Okay. Now, to solve this, what can we do here? Well, if we say, to get rid of this term over here, let's make x a negative 1. So let's say x equals negative 1. So when I plug this in here, negative 1 squared plus 3 and negative 1, and that all gives me negative 3. Plug in a negative 1 here, it'd be 1 plus be 3a. And negative 1 plus 1 is 0, so that means this 0 times this is 0. So in solving this, I get a is equal to negative 1. Okay, now, if I take that negative 1 and I plug it in up here, okay, right here, I'd have the equation x squared plus 3x minus 1. Well, if I put a negative 1 in there, be negative x squared minus 2. Okay. Okay, so what's going to make this term a 0? Okay, if I get rid of this term here, let's say that x is going to equal 0. So if I plug a 0 and a 0 in here, I'll have negative 1. A 0 here gets rid of that. So I have negative 2. 0 here gets rid of the b. So I just have plus c would be a c. Times 0 plus 1 is 1. So c times 1 is just a c. So I have this equation to solve. Add the 2 over. I get c is equal to 1. Okay. And if I know these two, okay, I can plug that in here and here. So I would have x squared plus 3x minus 1 equals, the a is negative 1, so negative x squared minus 2. My c is a 1. I just have bx plus 1 and x plus 1 there. So to make this part a 0, I want to get the b by itself, so I want this part over here to be a 0. So I'm going to make x a negative 1. So when I plug in a negative 1 here, I get 3. Negative 1 squared is 1, so negative 1 minus 3 would be negative 3. Plus the b plus 1 here. I'm sorry, I want to use a 1, not... Sorry, I don't want to use negative 1. I want to use 1. Okay, and this is why I want to use 1. If I use negative 1, that makes this a 0 here, and 0 times this is still going to be 0, right? So I'm down to 1 variable, so really I could use any number. I'm just going to use 1, because b times 1 would be 1b, right? So I'll just keep b by itself there. So when I plug that in, 1 squared is 1, minus 1b 0, so it'll be 3. And negative 1 squared is negative 1 minus 3 is negative 3. Plus b is x is a 1, so 1b plus 1. And 1 plus 1 is 2. Okay, so now I'm down to one variable here. Like I said, I could have used any number at all here because I'm down to one variable, so any number at all to plug in. So when I solve this, add that 3 over, I get 6. Distribute that through is 2b plus 2. And subtract the 2, you get 4. Divide by 2, you get 2. Okay, so I know my answer is going to be my a, which was negative 1, plus the b, which is 2x, plus your c. And there is my answer. Hey, we're going to look at one more form, repeated quadratics. So we did, if they're linear factors, right? Our factors were x plus 2, and x minus 2. We did repeated linear factors like x minus 1, x minus 1, x minus 1. We did a linear and a quadratic. And now we're doing repeated quadratic. Okay? Okay, so here we go. Okay, so we know that we're going to break it up into this quadratic. Remember, we have to make two terms with it, right? ax plus b over the x squared plus 1. We have to do the x squared plus 1 squared now too. So it's also quadratic, so we're going to do cx plus d over the x squared plus 1 squared, two of them, plus the linear one, e over the x minus 1. Okay, so we ought to find a, b, c, d, and e here. All right, so to do this, let's solve it. Okay, so I'm going to multiply by these factors here, by x squared plus 1 squared and x minus 1. So these and these will cancel out. I'll have 2x. This and one of these will cancel out, so I'll have ax plus b times the x squared plus x and the x minus 1. Now cx plus d, two of them will cancel, so I'm just left with this x minus 1. And here the x minus 1's cancel, so I'll have e times x squared plus 1 squared. Okay, get ready. Okay, here we go. Okay, so when we solve this, let's first do this. Let's say if x equals 1. Okay, if I plug a 1 in here, I get 2 times 1 is 2. And if I plug a 1 in here, 1 minus 1 is 0, so that whole thing is 0. 1 minus 1 is 0, that whole thing is 0. And if I plug this in here, I get 1 squared is 1, plus 1 is 2, 2 squared is 4, so I have 4e. So in solving this, I know that e is equal to 1/2. Okay, so that's pretty good, right? Okay, so I got the e. So now let's take that e and plug it in right here. So then I'm just going to rewrite all this. Okay, if I have a 1/2 right here. Okay, now what I want to do is I want to multiply all this together. Okay, I know that this times this is going to be x to the third minus x squared, right, if I multiply through, plus x minus 1. And if I take that and multiply it by this, ax plus b, distributing through, I would have ax to the fourth minus ax to the third plus ax squared plus ax, minus ax, because minus 1. Okay, I'm going to take the b through, so b to the third, I'm going to put that with my other to the third powers here, b to the third, x to the third, negative bx squared plus bx, and minus b. Okay, over here I'm going to multiply these together. So that times that is cx squared, so I'm going to put that with the x squareds here. And negative cx plus d minus d. Okay, and then over here, if I square this, multiply it by itself, right? So I get x to the fourth plus x squared is plus 2x squared and plus 1. If I take that 1/2 and multiply it through, I have 1/2 x to the fourth, so I'm going to put that 1/2 x to the fourth right here, plus 1x squared, so 1x squared, and plus 1/2. If I combine all those like terms together, I'll have a plus 1/2 x to the fourth plus negative a plus b x squared, x to the third. Take all your a squareds here. It'll be a minus b plus c plus 1. X squareds. My x's here. Negative a plus b minus c times x. Then my hold on a second here. I messed up when I multiplied right here. This should be dx. This should be dx right here. And then minus d. Okay, so my x's here should be negative a plus b minus c plus d x's. Okay, and then our constants is a negative b minus d plus 1/2. Okay. Whew. Now, this is what we're going to do to find out the a's and so forth. We're just going to set these equal to 0 here. Okay, I'm going to do this up over here. We're going to come up here. Okay, so I'm going to set a plus 1/2 equal to 0. I get a is equal to negative 1/2. So I found my a. I know that negative a plus b is going to equal, we're going to set that equal to 0 as well. So negative 1/2 makes 1/2. So b would equal 1/2. Sorry, negative 1/2, right? Subtract it over. I'm going to do the next one here. I know my a minus b plus c plus 1 is equal to 0. So my a is negative 1/2. My b is a negative 1/2. So negative 1/2 makes positive 1/2. Those cancel. I'll get c is equal to negative 1. Okay, the next one, I have negative a plus b minus c plus d equals 0. So negative 1/2 is 1/2. My b is a negative 1/2. My c is a negative 1. So negative 1 makes it positive 1. So those cancel. Subtract that over. I get d is equal to negative 1. Okay, and I already know that my e, right? I already knew my e there as well. I kind of made a mistake there with this one. With this, I'm going to say that x equals 1. So I'm going to plug a 1 in here. So 2 times 1 is 2. So this is going to equal 2 here. So when I solve this, subtract the 1 over, I get d is equal to a positive 1. So I know my decomposition is going to be the a, which is negative 1/2, x plus the b, which is negative 1/2, over my x squared plus 1, plus my c, which is negative 1x, plus my d is 1, over x squared plus 1 squared, plus my e. Whoop, e was 1/2, so plus 1/2 there. Over the x minus 1. Okay, and there is my final answer. You can also bring the 2's down here, so you'd have a 2 out front with that if you'd like to do that too. So that's some good problems right there.